I'm going to talk about how to use these tables of mass moments of inertia. So find one, pull one up on the internet, download one, pull out your textbook so we can all look at this together. So, and to demonstrate this, I'm going to do an example at the same time. So pull out your table and let's talk about this example. So in this example, I have an airplane propeller. Forgive me, we're going to pretend this is an airplane with a really massive propeller. We have an airplane propeller on the front of an airplane. It's got a radius of 1 meter and a mass of 25 kilograms that's uniformly distributed. And we want to calculate the mass moment of inertia. And we could do this using our integrals and calculus skills if we wanted to, or in this case, I'm going to work on using the tables. So on your tables, we have to decide what this most looks like. What does this propeller look like? And I'm looking at my mass moments of inertia. Need a marker. And to me, it most looks like a slender rod. And I think that's a pretty good assumption, especially if we're not looking at anything crazy happening on the propeller. And I've certainly drawn the most simplistic possible thing I could, because I'm an excellent artist. So I'm going to go ahead and use this slender rod. And if we look at the slender rod equation, you should have something that has Ixx, Iyy, and then you also might have like an Ix prime, X prime, Yx prime, or Y prime, Y prime, and a Z prime, Z prime. So let's talk about what those mean. The subscripts, the XX, YY, X prime, Y prime, Y prime, those mean the axis of rotation. And so you'll see in the diagram that you have those axes labeled. X, X prime, Y, Y prime, and Z are all labeled on the diagram. So you want to figure out what it is rotating about with a similar center of rotation. And for our propeller, the center of rotation is right in the middle of that rod, and it's rotating around like this. So in the textbook version, it would either be Ixx or Iyy. Those are equivalent. And luckily for us, it actually gives us the same equation. We should be concerned if it doesn't, both ways. And that's 1/12 ml squared, where m will be the total mass, and it says the length is the entire length of the rod. In our case, we were given just the radius, which is half of that is 1 meter. So our entire length will be twice our radius, or 2 meters. And now once we've figured out what the axis of rotation is, what the right thing from our table is, we found our right equation. Now we just get to plug in and find our mass moment of inertia. So here, mass moment of inertia should be 1/12 times the mass, 25 kilograms, times the total length, 2 meters squared, so that's 4, and this should give us a mass moment of inertia of 8.33 kilogram meters squared. And that's a quick little demonstration of how to use those tables and how to calculate mass moment of inertia. Nice work.